What was the reason, sir, for your sister-in-law that baby was dead? No?
Yeah, even they don't know the reason. Like the day before yesterday, at that time, like on 15th, they she went there and they gave the date that on 16th the delivery will happen. But when she went the next day, they declared that the baby is died, and we didn't tell her till 18th
Oh.
because it was like she was not also stable at that time.
Mm-hmm.
So that's
It's a boy or girl?
it was boy.
Boy.
It was the first baby, so it
Mm. Yeah.
we were also already there. We were expecting for a good
Mm.
news.
Yeah.
What can we do? Since then, even after, even yesterday, my friend's grandmother had a little, not accident we can say, but her health suddenly got worse. So
Mm.
even the whole night I was there. And
Mm.
before I came home, so
Mm.
after that I didn't got up in the morning and I woke up at around 8 or 9, I guess.
Mm. You're totally hectic from last 1 week, I think.
It's like the Jaipur is like the hospitals and everything is good here. So even
Mm.
friends from village also come here. So
Mm.
if you don't go, it anyway. Uh, yeah. So we configured CNI, I guess,
Yes.
right? The Calico one.
Yeah, yeah.
Okay. So next is in Docker, what we were doing, we were deploying containers, right?
Yeah.
In Kubernetes, the smallest unit that we can deploy is a pod. So Kubernetes launches pods. Pods are the smallest object in Kubernetes.
It's like it's like a container only.
Yeah, in that pod, the container a container will be deployed only. You can say this pod is encapsulating the container.
Pods contain a
Encapsulate.
containers.
Yes, pod contains a container.
Okay.
Okay, the containers encapsulated in a pod. You can treat it like a wrapper over the pod. Like the IP will be assigned on the pod. The
Mm-hmm.
volume will be attached with the pod. But in that pod, a container will be deployed. In some cases, if you want to deploy multiple containers inside a pod, that is also available. But
Then the
in
IP
that
address
case,
for each container is different or same
I, the IP will remain same.
for all containers.
No, no, not all containers. The
Yeah.
containers that we deploy in that pod only. Like
Mm.
each pod get its own IP address.
Yes, sir. But that container also have some IP address, no?
No, no. On that container, the container will use the IP address of the pod. That's why
Okay.
in 99% cases, we will be deploying a single container inside a pod.
Ah.
Okay. But in
Okay.
some rare scenarios, if you have a application where a container is just acting as a helping container for the other one, in that
Mm.
case, you can deploy multiple containers as well.
Okay.
We'll see a scenario like in which scenario we can use that we can deploy multiple containers inside a single pod.
Mm. Okay, sir.
So here what we'll deploy is a pod.
Mm.
Okay. So right, IP address will be assigned on a pod only. Volumes will also be attached on that pod. volumes will also be attached to that, to the pod. The container inside the pod will use the resources from pod. Okay, so it will, if the container wants to interact with the outside parameters or any other container which is in another pod, so they will use this IP address only to communicate. So it will be like this. Let's say this one is a pod, and that a container has been deployed. Change the color for this. So this one is a container, this orange, and this red one is a pod. If we want to deploy multiple pods, we can deploy them, and they will be deployed in the cluster that we have. If we have 5 worker nodes, it will be deployed on any of the worker nodes which we have. Mainly it will use the rank method to check the priority on which it will, in which node it should be deployed. It will check on which the most resources are available, and on that one the pod will be deployed. So who checks for that? Which factor check for that?
kubectl.
Cube scheduler.
Huh?
Cube scheduler will see that. Cube scheduler will decide which pod, which node is fit for deploying the pod.
Yes.
Okay. So let's see. If you want to deploy a pod, if you want to create a pod, there are two methods. There are two methods to create, or we can say deploy pod in Kubernetes. First one is we can deploy it via using the command, and the second method is to deploy it via a file.
Okay.
So we will create a YAML file which will be called a resource file, or we can say an object file or a definition file. So by using that method, we can deploy the pods. Okay. So in that YAML file, we will write the configuration, which type of pod, from which image it should be deployed. Okay. And Kubernetes will use that to deploy the containers, deploy the pods.
Okay.
So let's go here, connects. Sudo su hyphen. So right now, if we want to check all the pods which are available in our system, we will use kubectl. And before checking the pods, let's check the nodes. Kubectl get nodes. All the nodes are in ready state.
Nodes means this worker nodes is it means worker nodes is active.
Correct. Worker node is active and it is ready to use. So by this kubectl get nodes, we can see the status of our cluster. How many machines are there? Are they ready or not? Everything.
Okay.
Okay. If we do kubectl get pods, currently we have no resources. Okay. If we want to run a pod, the command is kubectl. What we want to do? We want to run a pod. Let's name the pod as pub server and hyphen hyphen image. Let's say I want to deploy an HTTPD container inside the pod. So if I press enter, and now if we do get pods, see, right now 0 out of 1 is ready. That means There is only one container inside the pod and it will be ready in a minute. If we see it again, now it is in running state. This restarts tells us how many times the pod has been restarted. So 0, it has just been created. Then
That
the
is
age.
that is
Hmm.
pod, not a container, right, sir?
Yeah, in that pod, this ready state is showing that in that pod a single container is there, and that is
Already.
in running state.
Okay, so that container, in the sense, for HTTPD is the image. For that image, we already created a container.
Correct. Like in
Okay.
Docker, what we were doing, Docker run hyphen hyphen it and
Yeah.
the image name and name. Okay.
Yes.
So right now, the name we have defined for the pod. The pod name is web server.
Website.
In that pod, a container has been created with the image that we provided here, and the image is
Okay.
HTTPD.
Okay.
If you want to check the details regarding this particular pod, you can use kubectl get pods. You can increase the output via -o wide. So name is web server. It's in running state. Age is 87 seconds, and the IP is 192.168.
Uh,
227.194.
okay. This is to check the status of that particular pod.
Correct. To of the particular pod, or if we have multiple pods, it will show us the status of all the pods. Where it
Okay.
is deployed, it was deployed on worker 2 node.
Okay.
If we do
Here we will
curl,
get IP
mhm,
address as also.
mhm, yeah, the IP address
Here.
of the pod as well.
Okay.
So this is the first method, and this detail we are only checking the bare minimum we can see. If you want to check all the details regarding this pod, you can use kubectl describe. Okay, one more thing. Like right now, this tab option is not working. Like even if I'm pressing tab,
Hmm.
it's not completing the commands. Okay. So if you want to enable the tab completion, you need to install a package here. First is apt get install bash completion. Okay, the package is already installed. Let's enable it for Kubernetes. Bash completion ctl. So whenever you want to look for anything regarding Kubernetes, it's better to go for the documentation of Kubernetes only, official documentation. Okay,
Okay. Hmm.
because in that documentation they have explained it very easily. So package is already installed. Yeah, if you want to enable it for a user, you can use this. If you want to enable it for the whole system, we'll use this command. So just copy, go to the machine, paste, enter, exit, log back in, sudo -i kubectl. See, this time I only wrote des and then used tab, so it completed the command.
Hmm.
So it will be very easy to work with. Like if you do press only D and then tab twice, it will show you all the options which starts with D. If you just press tab after kubectl, these are the options that you can use here. Okay.
Okay.
So right now we want to check the details of a pod. The command is kubectl describe. Now with describe what you want to put, again press tab. All these resources are available by which we can describe here. If you scroll down, we have multiple resources which you can be described. If you want to describe a node, that is also possible. If you want to describe a pod, that we can also use here. Okay. So kubectl describe pods, and the name of the pod is web server. So the name of the pod is web server. Some options are here which we'll discuss later on, like namespaces, priority, service account, node, on which node it was deployed,
What?
worker2.srk.com.
Yes.
IP address of that node is 172.131.5.119, the private IP.
Okay.
Okay.
Private
Start time,
IP.
yeah, the private IP.
Okay.
Then it is showing us the start time, labels which are used, which will be used later on. Okay. If we go status, it is in running state. IP address on the port 192.168.227.194. Then the container ID in Docker we saw every container gets a container ID.
Yeah.
So here as well, the container ID is there. Which image was used?
HTTPD.
HTTPD. Right now we haven't exposed any port here, so that's why it's showing none. State running started. It is showing us the time when it was started. If you scroll down, you can also check the volume option here. Okay, if you connect some volumes, it will show us here, and some logs regarding this particular pod is also available. Like which type of log it is. It is normal type. Reason, it was scheduled. When it was scheduled, 5 minutes 19 seconds ago by default scheduler, and the message was successfully assigned web server to worker 2. So kube scheduler decides where to deploy the pod, right?
Mm-hmm.
So here
Yes.
also the scheduler decided that this web server will be deployed on the worker
Worker.
node 2.
Yeah.
There it pulled the image httpd. The image was pulled successfully in this much seconds and created and started the container.
Okay.
Okay, so each and every log can be seen here for this pod only.
Mm.
If you want to check the details or logs regarding your nodes, so instead of describe pods, we can use describe nodes. Which node you want to describe? worker2.srk.com. So there it is. Okay.
So when we put command like kubectl run web server hyphen image equals to httpd or nginx whatever the image. So
Mm.
uh, in that time the pod will create and automatically the container will start.
Yes,
Okay.
the container will start in that particular pod.
Okay.
So if you see here, first of all, if when we describe the node, it is showing us the name of the node. Some labels are assigned on that node, which can be used later on to check and verify. Annotations we'll talk later. Creation timestamp on 15th December. This node was created.
Mm.
Okay. Then if we see the logs here, network unavailable, false. It is showing us the time and what's the reason? Calico is up. Calico is running on this node. Let
Mm.
me just make. So kubelet has sufficient memory. Whenever this particular container was deployed, not the container. This node was up. It will check the details. Who will check it? Kubelet will check it. Okay, we have configured kubelet on all the machines. So after the machine is ready, here kubelet told the API server that the machine is in ready state, you can use it. Kubelet is posting ready stated, app armor enabled. Like in Red Hat, we have SLNX, right?
Yes, sir.
In this one, we have app armor. What's the IP address of this particular node? How many CPUs are there? Storage, memory. Okay. How much of them is allocable? System information regarding that particular node. Okay, namespaces we'll talk later. How much CPU will be assigned or have been reserved for the pods? So allocated resources CPU is 25%. The pods can request up to 25% of the CPU for now. If we see starting it was started 22 minutes ago by proxy. It is showing us. Okay.
Yes, sir.
Then you can check the logs here. So it was not ready at 17 hours ago. Okay. So we can use this command describe nodes, or we can use describe
Pods.
pods to check the details of the
Pods.
specific pod or a node. Okay.
Yes, sir.
If you want to get help regarding kubectl, you can use kubectl --help. It will show you all the commands that are available. Basic commands: create, expose, run, set, explain, get, edit, delete, deploy commands, cluster management commands, troubleshooting and debugging commands.
Mm-hmm.
This log command is there in Docker as well. We have the command to check the logs. Here,
Yeah.
if you want to just check the logs of a pod, you can use kubectl logs and the name of the pod. PER. So it will show you the logs which are on that particular pod. Okay.
Yes, sir.
Then kubectl get pods. When we did this, we used -o and wide option. Check the details a little bit extra compared to this command. Okay.
Okay.
Just like this in pods, we can also check it for the nodes as well. Kubectl get nodes. You can use -o wide. So it will show you the kernel version, operating system, the IP address of that particular server. This was if we want to deploy the container, deploy the pods using the command method.
Mm.
Okay. And if we only wanted to deploy a single pod, we could have done that. Okay. Next, let's say one more thing. Right now, when we did get pods, if we check it again, so currently only
One
a
pod is
single
there.
container is there in that
Yeah.
pod.
Mm.
So where you might need multiple containers, let's say we don't have this Kubernetes for now. If we only work with Docker, okay.
Yes, sir.
Have you ever converted a PDF file to Word file online?
Yeah.
How do you do that?
I use some. tools, online tools to
Mhm.
convert.
You upload the file,
Yeah, and
they
then
will
I downloaded.
they will convert it, and then you can download it again.
Yes.
Right. So let's say we have two containers. We have this application running on which we can convert the files. So two containers are there. First container, what it will do, it will handle the request, handle the client request. That means it will give you the option to download and upload the file. So uploading and downloading will be done at this point. Okay.
What uploading and downloading, sir?
The file, let's say we are creating an application to which will convert the PDF file to Word file or vice versa.
Oh,
Okay. So
okay.
if you are a user who is using this application, what you'll do is you'll upload the file, and once it has been converted, you'll download that file, right?
Yes.
That's what we do. So you will connect with this container, right?
Yes, sir.
From the outside world, the request of the user will come on this container only. Say you are accessing from your laptop. This one is your laptop on which you have a file. Let's say aws.pdf. You want to convert it to aws.doc. Okay.
Yeah.
So we have deployed a website on the container, and when you make a request, the request will go on that container. There you will upload the file. Then this first container will send the file to another container which is running in the environment. There the conversion will happen.
Mm-hmm.
File will be converted, and once the file has been converted, what this container will do,
It gives input
it gives it back
to
to the
again.
first container.
Yes.
Okay.
Yeah.
And from there you can again download the file. So if we just create a simple application of converting, which will convert the files, we can do it like this.
Okay.
Okay.
Mm.
Here you can get the file aws dot. But if we only used a single container, let's say after some time the load was increasing and this container is not able to handle the request, what you need to do now?
We have to add another instance, another pod.
No, if we are not talking about pods right now, we are only talking about Docker. If you deployed it on Docker, what you'll do?
Then we have to create another container, sir.
Single one container or multiple?
It means you are saying in container, inside the container, one more container.
No, not inside the container. Let's say on this machine,
Ah,
like this container is only able to handle 1,000 requests for now.
yeah.
Let's assume. Okay. So both of these are containers are only able to handle 1,000 requests. And
Yes.
once they are having that much request, they will not be able to accept more requests. What
Mm.
you will do now? This one is your server.
We will deploy another container.
You will deploy another container with the same configuration.
Yes.
And we need
Or
to deploy two containers,
yeah,
not
yes.
only one.
Yeah.
Correct?
One is for that to convert, and the other one
Yes.
is for to upload. Download.
One will be used for converting it, and another one will be for upload and download.
Yeah.
So now we need to deploy two containers. Again, if they are full, and now we need to deploy more. Again, we need to deploy 2 containers.
Yes.
And if by chance something goes wrong and only this container fails, the one which was converting the file,
Mm.
what you need to do is you need to check which container is being failed and you need to restart it again.
Yes.
Okay. The load balancing that can be done, it will be complex, but it can be done. So we are not talking about that part right now. Like the load will be divided on all these containers, on the top
Containers.
containers. But
Yes.
when the request will come on this container, the file was uploaded, no issues, but it is not able to convert because this container is not working.
Yeah.
So you need to deploy this container again. You
Mm.
need to monitor the container continuously.
Yes.
Okay. With the help of pod, what happened here is these 2 containers were encapsulated and put inside a single pod. So now the pod will have the configuration that 2 containers must be in running state always.
Mm.
If a container is down, that means the pod will fail and we need to deploy another pod. And when another pod will be deployed, what will happen? That pod will by default have 2 containers. We don't need to deploy them one by one.
Okay.
Okay. So
Yes.
that is the main advantage of using a pod here. In case if you have a website in which a helping container is being used, like this bottom container, it is not directly communicating with the client. It is only communicating with this container,
Mm-hmm.
correct?
Yeah.
So in that case, you can use it. But we also have a drawback, like if something goes wrong with this one, the whole pod needs to restart.
So here, if there is any problem occurs in a pod, means the entire the two container will get stopped.
Yes.
So automatically the another pod will deploy, or we have to do so.
Yeah, we need to do the configuration. Like for now, we haven't gotten on that part, but we
Got it.
can configure the restart policies and everything. So it will automatically restart.
Okay.
Just like in auto scaling, we saw in AWS.
Yes.
What was happening? If something goes wrong in the instance, another
Another
instance.
instance will deploy.
Yes. Same thing we can configure here using replica set and replication control. So we'll configure that later on. Now it should be like the goal is that you should get the image why we are using a pod and what is a pod actually.
Hmm.
So pod is the smallest object which will be deployed, which can be deployed in Kubernetes. And inside a pod, we can
Contain.
create the containers will be created and we can also create multiple containers.
Hmm.
Okay.
But not a main container. So we can create only one main containers. In that container, we can add some, like, supporting
Helping
containers like
container. Correct.
okay, because the pod have only one IP address. So inside the
Right.
IP address, we can deploy one application. That's it.
Hmm. Yes.
Got it.
Okay. So that's why I said that in 99% cases, you will be deploying a pod in which only one container is there.
Hmm.
Okay.
Yes.
Even if you have a website where you want to connect two different containers, so what we'll do here is deploy 2 pods and then connect them later on.
Okay. And one more
So
question, sir. Here,
yes,
one main website. So I have a one application. I want to deploy one application, which uh, which contains a database server as well. So web server I deployed in the pod one. In that only I can deploy a database server also.
yeah, you can deploy it, but what will just give me a minute.
We will
Uh,
link the
just a second, Nandish, 1 minute.
yes.
Sorry, what were you saying?
So I'm asking, in one pod, we are going to install, sorry, we are going to deploy two containers. In that container, one container web server, and in another container uh, database server,
Hmm.
and we will link database server to web server through private IP address.
Yeah, like if they're inside the same pod, they don't need a different IP address to communicate. We can
Okay.
directly use the port and they can communicate. But the issue will be that if you have 100 containers, okay,
Uh,
in those 100 websites will be running and 100 database servers will be running.
okay.
Now the issue will be regarding the storage.
Mhm.
They will be using the same storage for both the containers. They will be using the same volume.
Okay.
Okay,
Yes, sir.
so that can be done. Like we can use it like that as well, but mostly we will deploy them separately.
Okay.
So, so the first method we already saw that we can use
Command.
commands to deploy a container, deploy a pod. Okay,
Yeah.
just name this toolbox as pod. So pod one, pod two, pod three. Yeah. Okay, so the first method was to deploy the containers, deploy the pods using a command. Next method is to deploy them using
Fine.
file, in which we will create a YAML file. We can create a YAML file which will be used as a, we can say, definition file, or you can say resource file or object file, whatever you want to call it.
Basically, it is in YAML format,
It is in YAML format.
YAML language. Okay.
And just like as we saw it in playbooks, it will contain key values, key value pair.
Yeah. Mm.
Okay. So at least 4 entries must be there always in that file. In the resource file, 4 entries will be there. The first entry is API version. So whatever resource we are using, whether we are creating a pod or later on we will create deployments, replication sets, or replica set replication controller. So whatever we create, there will be a specific API version for that. Okay, we need
Mm.
to define that here. Second is kind. What kind of resource we are creating here. Third is metadata, data of data, or you can say information regarding the data. What this particular, let's say if we are creating a pod, for pod, this API version will be v1. The kind will be defined as it is a pod. In metadata, we can define a name for that pod. Let's see the name of the pod. Name of the pod should be
Web server.
web server, website, web server we have already created. So name of the pod, after that we need to create one more entry, that is spec, and in spec we will tell the information regarding the containers that we want to deploy. If you want to deploy multiple containers, you'll give a list here. First is name of the container should be, let's say, ABC. Which image it will use? It will use HTTPD or Nginx, whatever. If you want to add one more entry, you can add it here. Again name, DEF, and again image. Got it?
Yeah.
So let's say for now we want to create a pod with a single container inside that. So we need to write the resource file like this.
Hmm.
Okay, we can also provide some labels there. So we'll talk about the labels later on.
The first
In
three
metadata, we
lines,
can add here. Hmm?
first three lines is mandatory.
No, no, even like let me just remove them for now. These four entries we need to make. Like this API version should always be there in the file. Kind should always be there. Metadata should always be there. Spec should always be there. In that, we will provide different values. Okay.
Okay.
So as we create the files, you'll be able to get what the values will be. Let's create a file directly. Let me give you a more clear idea regarding this. To like right now, if we do kubectl get pods, a single pod is running since last 32 minutes. If you want to remove this pod, you can use kubectl delete
Stop.
pod
Okay.
and the name of the pod. Name is web server. The pod web server deleted. If you again check it, kubectl get node get pods, nothing is there.
To stop the pod.
Yeah, we can use stop in that case. Right now, we deleted it because we want to create a pod with the
Fine.
file method. So for file, let's use pod.yml only. So vim pod.yml. Here, the first entry will be API version. And in API version, V should be capital. Okay.
Hmm.
For pod, the API version is V1. Next entry is kind. Next entry will be metadata. And the last entry should be spec. Okay, so these four columns, four keys we should be there. Now in kind, what we are creating right now, we
Pods.
are creating a pod. So we will write pod with P capital. Okay.
Sir, here, of course, in Kubernetes means we have to create a pod only. So we have to write only pod or anything apart from that.
No, here we will write pod only. If we are creating a pod separately, later on, if we will create like deployment, we will create services. So in that case, what kind of resource we are creating, that will be written here. If
Got
we
it.
are creating a deployment, we will write deployment.
Got it. Sir. And what
Then
is the P1, sir?
that's the version of API version will be there for each and every resource. If we are
Okay.
creating a pod, API version for that is V1. If we are creating a replica set, the API version for that is apps/v1.
Hmm.
Okay, so versions will be different for different kind of resources. In some of them, it will be same as well. Okay.
Hmm.
Next, metadata, in which we want to provide the name of this pod. Let's say Nandesh. And in spec, we will write what we want to deploy. So we want to create containers. Then name of the container should be web, and which image should be used. Let's say
HTTP.
Nginx or HTTPD. If you want to deploy or create a single container inside that pod, you will write a single entry. If you want to create multiple, you can give the entry like this:
Okay.
abc and then image, whatever image you want to use. For now, we are only giving a single container here. Save the file. So if we do ls, it's here pod.yml
Yes.
kubectl get pods. Right now we don't have any pod here. So use kubectl. We want to create using a file. So hyphen f, and the file name is pod.yaml. So a pod has been created named Nandesh. It is in. It is not in ready state right now. You can use watch command here to do the live monitoring. Now it is in ready state.
Okay. So the Nandish is a pod name.
Yes, Nandesh is the name of the pod. Inside that pod, what we created a container,
Yeah.
right? So if you do kubectl describe pod Nandesh. So the container is running off
Nginx.
Nginx. The IP address that will be used is the IP which is assigned on the pod only.
Worker node 1.
It was deployed on worker node 1.
Okay.
Creating container named web.
So where we mentioned the container name, Nandish, you mentioned where we mentioned that one.
In
Where?
metadata, we provided the name of the pod. In
Yes.
containers, we provided the name of the container and the image that we wanted to use.
Got it. Sir.
We go here, pod, Kubernetes. So what is a pod? Pods are the smallest deployable unit of computing that you can create and manage in Kubernetes.
Yes.
If you go down, see, so name of the pod, any spec, name of the container, image. If you want to enable the ports, which we'll see later, you can also export the port. So just like we created a pod with the command, what we did if we wanted to delete that pod, we used kubectl
Delete
and delete and
pod
the
name.
pod name. Right now, what we want to do is, let's say we want to delete the pod that was created with this pod.yml.
So
So cube,
uh,
hmm,
can we check the status like whether it's uh, the- whether the pod is running or not? The same like kubectl.
kubectl get pods.
Okay. 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 Okay.
So
And can we stop that? Let's stop and after can we check the status?
kubectl, it's not the stop option. Option will be different. Just a sec. It will be wait. Stop this particular pod. wait is used for that. We can't stop it manually. It will automatically work with the application set and controller.
Okay.
Okay, the manual option is not available here. When we create that replica set or the controller application controller option, there it will be managed by default.
Mhm.
Okay, so what we want to do here is right now we want to delete this pod via the file. For that, kubectl delete -f pod.yml. The Randesh pod will be deleted.
Okay.
But let's say by using this method, the file method, we deployed a pod.
Mm.
The pod is nandesh.yml. In that pod, a container is in running state. Now, if you want to create multiple containers, multiple pods, what you need to do? You need to run the command again.
Yes.
As soon as you run the command again, what will happen? Another pod will be deployed.
Yeah.
You run the command again, one more pod will be deployed. Okay.
Yes, sir.
Some of them might be on the same worker node.
Mm.
Some of them might be on different worker node.
Yeah.
Okay. Let's say these are on worker node 1 and on worker node 2 we have another pod. Same Nandesh pod is there. What's the issue now is here we only deployed 4 pods. What if we want to deploy 400? We need to deploy run the command 400 times.
Yeah.
So that will be very tough. Other
Yes.
than that, what about the load balancing part? Like what we want is the load should be divided in all the pods.
Mm.
So if we configure that manually, that's very complex. That can
Yes.
be achieved, but it will be a very lengthy process.
Yeah.
Okay. So even if they were on same node, the process would be complex. So the next thing, these auto scaling part or you can say high availability part will be handled by controllers. Which controller did we talk about when we were doing the installation? There was a controller. What was the name of that?
Uh, this in Kubernetes you're talking about.
Yes. Like on worker on master node, we configured multiple things.
Yeah.
First was cubes cube sorry API server, cube API server. Next one was cube scheduler. The next one after that was
And
cube
I,
controller manager.
yes, I noted down all the things, but that is in different things actually.
Able to remember, don't worry. Once you go over it 3 4 times,
Yeah.
it will be there. So Kube Controller Manager. So what that Kube Controller Manager was doing, it was monitoring all the pods on the throughout the cluster. Okay, if we had 20 pods across the cluster, and we want to keep them like that only. What we want is at any time 20 pods should be in running state. So that was managed by Kube Controller.
Okay.
If we had more than 20, it will remove some pods. If we have less than 20, it will deploy some pods.
Mm.
Just like what we had in auto scaling. We provided a desired value, right?
Yes, sir.
And according to that desired value, the number of instances was changing. If the
Yeah.
desired value was 2 and the current number of instances was 1, it was increasing the instances. If the desired value got decreased, the number of instances also decreased,
Mm.
right? So
Yeah.
that thing is managed by Kube Controller Manager.
Controller. Yeah. Okay.
Okay. And in this, the controllers that we will be talking about, we have three. First one is replication controller. Next is replica set. There is a minor difference between replication controller and replica set. Okay, we'll
Mm.
talk about them, what the difference is. You can call this RC, this one is RS, and one more is deployment. And why we are using them? For the high availability and the load balancing feature. Like
Mm.
if we deploy the pods manually, we don't get those options. We don't get high availability. It will not automatically uh, deploy some pods. Okay, we need to do those steps manually. But if we use these controllers, we can achieve that. Okay,
Yes, sir.
so we will be using them for high availability and load balancing feature. We can use following. What you need to do today is
Mm.
just check a little bit about just the basic
Okay.
definition or introduction about these replication controller, replica set, and deployment. And other than this, even if you skip this, you don't get time for these. You need to do the practice regarding the pod. Try to deploy them manually and deploy them using a
Fine.
file. The main thing is that it should be clear what a pod is and how it is
Mm.
different
It's
from
clear.
a controller. Okay.
Yeah.
So tomorrow we'll see how we can configure replication controller, replica set, and
Deployment.
deployment.
It means deployment means you are going to deploy the application in this container inside the pod.
No, no, that's not the deployment. Just it's
Okay.
just a word for a controller which they have provided.
Mm.
It's just a
Mm.
term. Just like replication controller, replica set,
Mm.
deployment is also kind of similar. Not exactly similar, but kind of.
Okay.
So for these, we will also create the YAML file only for working. Okay, so go through this. The
Sure.
file method we will be using that.
Mm.
Other than this, in our bash profile, in the file bash history or bash rc,
Mm.
so not history, bash profile or bash rc, we made an entry when we did the installation.
Yeah.
If you do vim dot bash profile, so we told what's the configuration file. Where is the main configuration file of
Kubernetes.
Kubernetes? That is
Admin.
admin.conf. So if we go here, etc kubernetes admin.conf. See, and this one as well, API version is there. Then some certificates are used here. IP address of the server, okay. Name Kubernetes. So whenever it is making a connection, it is using this configuration file
Hmm.
always.
Okay.
So if you want to manage your cluster from outside of that cluster, like right now, how many worker nodes? We have 3 worker nodes and
Yes.
one master, right? So if you want to manage your cluster from your Windows machine, you can also do that. What you need
Okay.
is that, first of all, kubectl. It should be installed in your system, by which you will be running the commands. And
So,
you must have this admin.conf.
okay.
Okay, so we
So
will be
this
managing. Mhm.
this cluster in the sense which including all the machines and whatever the parts are there, we all include call it as a cluster, right? Only managed nodes. Sorry. Only worker nodes or including managed nodes also.
Worker node and the master node as well, both.
Okay. Okay.
Like all of the machines in our Kubernetes or which is being worked by Kubernetes will come under the cluster.
Okay.
Okay.
Hmm.
They can be managed from outside the cluster as well, but you must have these things with you on the system from which you want to manage it. Okay. So kubectl command should be there, admin.conf should be there, and in that admin.conf, you must have the public details. Like right now, if you see here, see the server IP is private IP address,
Hmm.
right?
Yeah.
So it is connecting between these worker nodes and the master node privately.
Yeah.
If you want to connect it from outside the network, you must use the public IPs.
Okay.
Okay. We will be using it with the master node only, and in real scenario as well, you will be mainly working with the master node. But
Hmm.
if you, in some case, if you want to manage it from outside of the network as well, that too is also possible.
Okay.
kubectl get pods, no pods found. Nodes are in running state. Kubectl get nodes. So tomorrow we'll see about replication controller, replica set, and deployment.
Deployment.
Let's stop the machines. Instance state. Okay. So tomorrow evening,
Hmm.
most probably 7 o'clock. If the time is different, I'll let you know.
Okay.
Otherwise, it will be 7.
Okay, sir.
Okay.
Evening only.
Yeah, evening only.
Then, sir. Okay.
Okay.
That's it.
Yeah. That's it for today.
Okay, sir.
Okay. See you tomorrow.
Yeah. Thank you so much. Bye. Have a
Welcome.
great
Bye bye.
night.